I made the train tracks. And then since there wasn't any plus coins, I just divided each side by 6. And I got C equals 6.
Perfect, perfect. All right, can you please pick a boy, preferably a volunteer, but not necessarily, for number 2?
Hendrik.
Okay, so for 6C plus 9, so, anyway, so I got C equals 10 because 6 times 10 is 60, and then I added 9 and that got me 69.
Okay, I totally agree, but we're going to do some train tracks.
Okay. So what I did was, I didn't write that down.
Okay. We're going to do it now, though. Okay, so what are we going to do first?
Okay, so we have 6C and then 69 on the other side, so we have to, so I divided, I'm going to subtract 9 from 69 because that's the add.
Okay, so you're not, so hold on a second, you're not subtracting 9 from 69, you're subtracting 9 from both sides of the equal sign.
Yeah.
So you're subtracting 9 from 69 and you're subtracting 9 from 6C plus 9. Okay, what do you get?
And I got 60.
6C is equal to
60.
Okay.
And then I just divided 60, and then I divided both by 6. And that got me 10.
No, it got you C on
Or
the
C
left side.
equals 10. Yeah, C equals 10.
Okay. So, Hendrik, you're totally right. You could do this problem the way you're talking about it, but the issue is, quite frankly, this is a very simple solving a linear equation problem. Things can get a lot more complicated, and we need a way to organize our work so that we can do the more complicated problems.
Okay.
So that's why we're learning this process, so that later we can use the process to do more with it. Okay. Hendrik, could you please pick anybody for problem 3?
Volunteer or no?
Preferably a volunteer, but not necessarily. It's your choice.
Okay. Grayson Manuel.
So what I did is I divided both sides by 6.
Okay.
And I got C plus 9 equals 20. No. Sorry. And that equals 13 and a half.
Okay.
Then I subtracted 9 from both sides. And I got C equals 4.5.
All right. Did anyone do this problem differently?
I did.
Okay. So, Cora, can you show me how you did your problem?
Well, mine was basically the same except, well, I did 6. Okay, so I did the equation, and then I did 6 times 9 and 6 times C, so then the equation changed to 6C plus 54.
That still equals 81. So
Yeah.
these equations are the same. As luck would have it, this is called factored form. And then this is called expanded form. Expanded form. Miss Karen's chuckling because she's seen a lot of that recently. All right, so go on.
And then I minused 54 from 81 and 60 plus 54. And then that canceled out the 54, so it was 6C equals 27. And then I divided both sides by 6. And I got C equals 4.5.
So we got the same answer. That's great. Both ways worked. Oh, okay. So we're even on boys and girls so far. So Cora, could you please pick anybody who's willing to try question 4?
I only see.
Let me guess.
Yeah, I don't see anyone raising their hand.
Anya,
No.
Will Ferris.
Okay, so Anya and Will Ferris both have their hands up.
Okay, Anya.
Okay.
Okay, so first what I did is I made this into, I forget, factored form, I think? Or
It doesn't matter. It doesn't. The vocab right now doesn't matter for you guys.
Okay, so I made it 5k minus 60 equals 3k minus 99.
Okay.
So first what I did is I added 60 to both sides, so it would cancel out the 60 on the left. And that got me 5k equals 3k minus 39.
Okay.
Then I subtracted 3k from both sides, which left me with 2k equals negative 39. So then I divided both by 2k to get k equals negative 19.5.
And there you go. Whew. So, Hendrik, are you there?
Yeah.
So, and be honest, you can say yes to this or you can say no. So your method for this one right here definitely got the right answer. Would you have been able to use your method on this one?
No.
Here?
No, for sure not.
Right. And so that's why we're looking at how do we create this process that turns these problems into something we can handle and deal with every time. So this investigation, this is the expectation for all of the problems, even if it's as short as this one right here.
Okay.
All right. To be honest with you guys, this is about as tough as it's going to get. So if you feel good about this problem right here, I mean, it had 1, 2, 3, 4. That's a 5-step problem. So, if you feel good about this, you're going to probably be just fine. All right. Are there any questions before we move on?
Nope.
All right. All right. So here is the investigation for today. For part A, you have parts 1 through 3. All you're doing are train tracks. That's it. This is really an investigation about repetition and practice using train tracks. That's all we're doing today. For question B, we have Corey, Hayden, and Jackie. And both students solved their problem, and they wrote down in English language how they did it. And so your job, I believe, is to make sure to figure out if they did their problems correctly. So really, it's a student error analysis for problem B. Are there any questions about what we're doing on this investigation?
Nope.
Okay, so that's all there is, folks. I want you to work in your small common rooms. So go work in your small common rooms. I know it's a lot of problems, but you can do this. You can crank through it. You're expected to work together, and then we will go through all of the answers at the end of class. All right?
You're leaving.
Small common rooms.
Addison wants to know, is there anything that I missed that I need to make up?
Oh, hold on a second.